Okay, so today we'll start with the numerical problems of electric dipole. So these questions are from your assignment. So you can write the answers directly in your assignment notebook. So have you kept your assignment notebook on your table?
Yes, ma'am.
Great. So let's start. This is the first question. Please read the question first. So we have two charges here, each of 1 microcoulomb, but opposite in sign. See, in an electric dipole, we have two charges which are opposite in sign. One is plus q, other is minus q, and they are separated by a small distance 2a, right? And here the distance is given, it is 1 centimeter. So calculate the electric field at a point distance 10 centimeter from the midpoint on the axial line of the electric dipole. So how do we find the electric field intensity on the axial line of an electric dipole? So we have a dipole here. Just draw the dipole first. One charge is positive 1 microcoulomb, other charge is negative 1 microcoulomb, and the distance between these two charges is 1 centimeter. So this is your 2a. And we have to find the electric field at a point distant 10 centimeter from the midpoint on the axial line. So this is the axial line. Okay, so from the midpoint, this is the midpoint of the electric dipole. Let this point be A and this point be B. So from the midpoint, we have to find the electric field intensity at a distance 10 centimeter. How will you do this? So this is your 2A is 1 centimeter, right? And your R is 10 centimeter. So we can see that R is very, very greater than A, right? In such a situation, when R is very, very greater than A, how do we write the formula of electric field intensity on the axial line of an electric dipole? क्या होता है बेटा? What is the formula? सी आप कॉन्सेप्ट भी यूज कर सकते हैं अगर आपको फॉर्मूला याद नहीं है तो, क्योंकि इलेक्ट्रिक फील्ड इंटेंसिटी को हम सुपरपोजिशन प्रिंसिपल से ऐड करते हैं, राइट? है ना? वेक्टर सम होता है of individual electric field intensities because of the charges present in the system, right? So you can use the concept as well if you do not know the formula, or you can directly apply the formula here. अगर आपको फॉर्मूला पता है तो डायरेक्टली अप्लाई करेंगे, फॉर्मूला नहीं पता है तो कॉन्सेप्ट यूज करेंगे. इस चार्ज की वजह से पॉइंट पी पे इलेक्ट्रिक फील्ड इंटेंसिटी क्या होगी वो फाइंड करेंगे फर्स्ट, and then because of this charge -1 microcoulomb we can find the electric field intensity at P point, and we'll mark the directions of both the electric field intensities and subtract. So this is the concept behind it. In the derivation of axial line, we use the concept and derive the formula. फॉर्मूला किसको याद है बताइए? हाँ जी, please unmute yourself and respond. E is equal to
RQ.
Yes, it's E is equal to K into 2P by RQ. So K is the constant. It is 9 in 10 power 9 Newton meter square per coulomb square. And P is the dipole moment. So what is the formula of dipole moment? It is the product of charge and the distance, no? Q into 2A. So just put the values. Charge is 1 microcoulomb. So just convert this into coulomb first. 10 power -6 coulomb हो जाएगा. Distance is given 1 centimeter है ये आपका, तो 10 की power -2 meter हो गया. Just multiply these two, 10 power -6 into 10 power -2. You will get 10 power -8. Coulomb meter is the unit. Always write the units, okay? Now put the values here in the formula. So E is, K is 9 into 10 power 9. 2 into P is 10 power -8 divided by R cube. R cube, R is 10 centimeter. So in meters we can write 0.1 meter, no? So 0.1 square or 10 power -1 square you can write. हाँ जी, आंसर क्या आ रहा है? It is R cube, no? It's not R cube, right? So R cube. Find the answer. It's 18 into 10 power 1 और ये आपका 10 की पावर -1 है नीचे, तो 10 की पावर -1 की पावर 3 हो गया, 10 की पावर -3 हो गया, ऊपर जाके 10 की पावर 3 हो जाएगा, राइट? हाँ जी, आंसर क्या आ रहा है बेटा? ऋषिका, आपका आंसर क्या आ रहा था? आपने किया हुआ ये क्वेश्चन?
हाँ मैम यही है आंसर।
18 into 10 power 4,
यस।
and the unit of electric field intensity is?
न्यूटन पर कूलम।
In standard form, we write like this: 1.8 into 10 is power 5 Newton per coulomb. So this is the answer. Please write this in your notebook. And those who haven't done, they can take the screenshot and write later. Which question is this in your
Ma'am,
assignment?
it's 51. And if we don't convert this into standard form, would our marks be cutted?
No, 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 no. Even if you write 1, 8, 4 times zeros, they will not deduct your marks. Should I clear the screen? Let's move to the next question now. Yes. Read the question now. So we have two charges, 20 microcoulomb and -20 microcoulomb. They are held 1 centimeter apart. Calculate the electric field at a point on the equatorial line at a distance of 50 centimeter from the center of the dipole. So what is the equatorial line? How do we draw it? आद्या, equatorial line क्या होती है बेटा?
इक्वल बीच से इक्वल लाइन।
फरहान,
जी मैम।
इक्वेटोरियल लाइन क्या कैसे ड्रॉ करते हैं?
बेसिकली परपेंडिकुलर बीच।
This is basically the perpendicular bisector that we draw. This is the equatorial line. ठीक है, पर फरहान देखो ऐसे बता सकते हैं, है ना? So
अच्छा
50 centimeter perpendicular bisector. So it bisects the dipole. It actually passes through the center of the dipole and perpendicular on it. Okay? It passes through the center of the dipole and it is perpendicular on it. So this distance is given. So 2a is 1 centimeter. So we can write this into meter again, 10 power -2 meter. And r is 50 centimeter. So 50 centimeter, we can write 50 centimeter as 50 into 10 power -2 meter. And charge is given, it is 20 microcoulomb each. So we can convert this into coulombs just by multiplying it by 10 power -6. So we have to find the electric field at a point on the equatorial line, somewhere here on the equatorial line at point P. Again, we can use the concept or the formula. You can apply the concept and do any question. Okay, even if you do not know the formula. Okay, but that thing will take time. है ना? Because concept apply करोगे, resolve करोगे vectors को, you are getting the two electric field intensities here at point P in different directions, and you are supposed to resolve the electric field intensities, and then you will add accordingly the horizontal component and the vertical component. So this is the way we do the derivation. And what is the formula?
KP by R cube.
Yes, it's Kp by R cube. So we can apply the formula directly. So E is equal to Kp divided by R cube. This is for, we use this when we take r very, very greater than a, and in this particular situation we can see that r is very, very greater than a, so we can neglect a. So first find dipole moment P. How do we find dipole moment? It is charge multiplied by the length of the dipole. Just put the values here, you'll get the value of the dipole moment. Charge is 20 microcoulomb, 20 into 10 power -6. Rishika, please turn on your camera. And the length is 1 centimeter, so 10 power -2. coulomb meter, right? So you'll get 20 into 10 power minus 8 coulomb meter as the dipole moment. And then we can find the value of E just by putting the values here. So what will you get? E is Kp by R cube. K is your constant. Its value is 9 into 10 power 9. P is the dipole moment. This is the value of dipole moment that we have just got. And R, this value is 50 into 10 power minus 2 square. Cube, sorry. ठीक है? Solve this for electric field intensity. हाँ जी, क्या आ रहा है बेटा? 9 2s are 18, 180 into 9 minus 8 is 1. In the denominator, we have 5. So we can write 2500, or we can write 25 into 10 power 2 into 10 power minus 2. 2500 we'll get for 50 square. 50 cube, okay. For 50 cube, we have to do. So in the denominator, 50 cube. 5 cube is 125. And we have this 10 raised to the power minus 1. So we can write 10 to the power minus 3. Now we can solve this. So it's 1800 divided by 0.125. We can write like this, or you can move this 10 to the power minus 3 to the numerator. It will become 10 to the power 4, and then you can solve it. What value you are getting? You can write 18 into 10 to the power 2 into 10 to the power 3. We can write like this, and in the denominator we have 125. Or we can write 180 upon 125. We can solve like this. We can write them together, and we have borrowed just 110 from here. So we are left with 10 to the power 4 Newton per coulomb. Now you can find 180 upon 125. So 180 upon 125 is 1 point. What will you get? 80 minus 25. 1.44 into 10 to the power 4 Newton per coulomb is the answer. Please write this. And what is the direction of E? In this particular case, what direction of E do we get? Okay, what is the direction of dipole moment?
Negative to positive.
Yes, so direction of dipole moment is this, and direction of electric field intensity in case of equatorial line, it is opposite to the direction of E. So at point P, this would be the direction of electric field intensity. Okay, opposite to the direction of dipole moment. Please write the solution. Take the screenshot, those who haven't done. किसी को डाउट है तो पूछ सकते हैं आप. आद्या, Anvesha, any doubt?
No, ma'am.
So an electric dipole of dipole moment, this is placed in uniform electric field, making an angle of 30 degrees with the direction of the field. Find the torque exerted by the electric field on the dipole. What is the formula for torque on an electric dipole?
P cross E.
Yes, torque is a vector quantity. It is a vector product of dipole moment and electric field intensity, or we can write torque as PE sine theta. So the value of dipole moment is given. P is given to you. It is 4 into 10 to the power minus 5 coulomb meter. Electric field intensity is given 10 to the power minus 3 Newton per coulomb, and the angle is given, it is 30 degree. So you just have to put the values here and you'll get the value of torque. Direct question है, इसमें कुछ भी नहीं करना है, आपको सिर्फ values को put करना है, you'll get your answer. Please do this. So torque is PE sin theta. Just put the values. P is 4 into 10 power minus 5. Electric
वो
field.
साइन थीटा क्यों हुआ?
बेटा sin 30 डिग्री। हाँ जी बताओ, क्वेश्चन क्या था आपका, डाउट क्या है?
साइन थीटा क्यों हुआ?
बिकॉज आप वेक्टर प्रोडक्ट लेते हो, जो टॉर्क का जो फॉर्मूला होता है वो क्रॉस प्रोडक्ट है डाइपोल मूवमेंट का और इलेक्ट्रिक फील्ड इंटेंसिटी का। तो क्रॉस प्रोडक्ट में हम कैसे करते हैं, ए क्रॉस बी किया था ना हमने लोअर क्लासेस में, 11th में किया था, राइट? तो ए क्रॉस बी में क्या होता है, ए बी साइन थीटा होता है ना। तो ये पी क्रॉस ई है,
चलो
ये
ठीक।
इसका फॉर्मूला है, तो पीई साइन थीटा हो गया। इसका आप डेरिवेशन करोगे ना डाइपोल मूवमेंट का, जो टॉर्क वाला, जिसमें हम एक्सटर्नल इलेक्ट्रिक फील्ड में डाइपोल को प्लेस करते हैं लाइक दिस। हैव यू डन दिस डेरिवेशन? ये डेरिवेशन किया हुआ है आपने, जिसमें ऐसा कुछ है, यहाँ प्लस क्यू चार्ज होता है, यहाँ माइनस
हम्म,
क्यू चार्ज होता है, और इधर ये लेंथ 2a होती है, ये एंगल थीटा फॉर्म कर रहा है, तो इसमें फोर्स एक्सर्ट होगा
हाँ,
टुवर्ड्स दिस,
करी तो थी।
है ना। हाँ, तो फोर्स इंटू आर्म ऑफ द कपल करते हैं ना हम, तो आर्म ऑफ द कपल इज दिस 2a साइन थीटा, तो F इंटू 2a साइन थीटा हो जाता है आपका। और F इज क्यू ई, तो क्यू ई इंटू 2a साइन थीटा हो जाता है। एंड Q इंटू 2a इज P, डाइपोल मोमेंट, तो PE साइन थीटा ऐसे आता है आपका ये। ठीक है, ये डेरिवेशन है इसका, यू माइट हैव डन, ये आपके नोट्स में यू विल फाइंड दिस डेरिवेशन। तो वी हैव दिस फॉर्मूला, वी कैन अप्लाई दिस फॉर्मूला डायरेक्टली एंड सॉल्व द प्रॉब्लम। प्लीज टेक द स्क्रीनशॉट। आर वी गेटिंग डेंस पावर -8 और -7 here?
-8 only.
-8.
-8. Should I clear the screen? We need to rejoin now one more time.